Hi, my name is Tim Seghetti. I'm a technical engineer in Cisco's IoT business unit, and I'm here today to present a demonstration of one of our management products called Field Network Director. And the context of this demonstration is to manage an advanced metering infrastructure. So perhaps you're familiar with advanced metering infrastructures, but just in case you're not, I'm just going to paint a high-level picture of what this is all about. We see a lot of utility companies that are adopting these advanced metering infrastructures or AMIs for short, to deliver a lot of value to their customers. For instance, BC Hydro, who's been a leader in this area, for 5 years now, they have deployed now over 2 million smart meters throughout the province, and this has resulted in lower costs in their operations, lower costs to their customers because they can capacity plan, they can make smarter decisions based on all the information that's coming in from these meters, as well as it provides customers greater visibility into their own power consumption and usage, businesses as well as individual consumers can make smarter decisions and reflect more efficient use of their power consumption, as well as from a troubleshooting perspective. They're able to identify the fault locations and isolate these and restore services that much more efficiently because of the increased information that these meters bring in. Now, what are the technologies? On the hardware side, well, we have individual smart meters. They're made by various partners. One partner we have a very close relationship with is Itron, and here's an example of one of their 4G enabled smart meters. In turn, these talk to, whether directly or indirectly, as we're going to see in our demonstration, to routers like our connected grid router. So these routers in turn are built for, all weather environments. You'll see that they're mounted in very difficult to reach locations, such as on a hydro pole, quite high up in the air. And so you don't want to be able to, you don't want to have to service these unless you really have to. So they have to be very reliable, performing in all kinds of weather, meeting all of these high availability requirements to really keep everybody's power up and available for them on maximum efficiency. Now, what's the overall technologies that allow this communication of an AMI? Well, one of the key technologies is called Resilient Mesh. So the network itself is very different than, say, an enterprise network or a typical wireless network in several ways. One, it's a very low bandwidth network. That's something to be aware of. So we're talking here about speeds up to 1.2 megabits per second. So low bandwidth, it's lossy, it's also low power, and it's also expensive. We mentioned some of these uplinks are 4G, and as such, every byte of data has to be well utilized because of the expense that is incurred in these transmissions. So all our operations, whether it's receiving the data, taking all these measurements, or doing operations such as firmware upgrades, all has to take into account these unique constraints of such a field area network, a resilient mesh network. We see that these networks are very, very large. We mentioned, for example, BC Hydro at 2 million smart meters. Well, since then, there's been other customers we worked with that are even much farther along in scale. We have one customer at 8 million endpoints and looking to go to 12 in a few years' time. And so to manage such a large scale network, we have to have tools that can accommodate these type of scales that can really meet the needs of an OT persona and operator, and can make that troubleshooting simple, but at the same time effective, and really contribute to the workflow that is needed in these environments. And to that end, our primary tool and what we're highlighting here is our Cisco IoT Field Network Director. So let's get into the demo now. Okay, so let's get into it. I'm going to log in to Cisco IoT Field Network Director. And what we have here is actually very exciting because it's not just a tool that we're demonstrating, but our engineering team has done something very marvelous in the background to make this a very interesting demonstration. They've developed an in-house tool called Matrix, and what this really is an effective digital twin. That is a complete virtualization of a utility network that's been fully virtualized such that every single meter that you would see out in the field is actually running as an instance on a virtual machine, running the exact same firmware within a virtual environment. The only difference between being a full digital twin is that this is not based on a real customer network, but rather it's a fictitious network. So it's like a clone of a made-up person. So in that way, it's like a virtual uh, digital twin, if you will. Now, the point being, the first thing I want to show is that what we've set up here is a field area network of over 2,200 devices. You can see here in the San Jose area, 2,202 devices that are being connected in exactly the same manner as they would in a real utility environment. First thing that usually I find very impressive is just the sheer scale. And this really is nothing. We talked about some customers that are 10 times this scale, BC Hydro, 2 million devices, or other customers that are 4,000 times this scale. And so it really is a very unique environment, a very challenging environment in order to manage all of these types of devices at these types of IoT scales. So we can see that all of these smart meters are connecting back to CGR router that's located right here. It's a Cisco CGR 1240 router. And let's pick one of these more remote instances of a meter to give us some idea of how they're connecting. So for example, here I've got a very specific meter that's out in the edge of Milpitas, which is just north of the San Jose area, and it's connecting not directly back to the CGR router, which is way over here on the left side of the screen, but it's actually taking 1, 2, 3, 4 hops. Each one of these lines is blue lines. Let me just grab it. Represents a specific hop. And then Field Network Director can give us details on each leg of these journeys, each individual hop. You can see the RSSIs, the receive signal strength indicators in both the forward and the reverse direction. We also have RPL link cost, that is a routing protocol for low-powered lossy networks. It's an acronym embedded within an acronym. So RPL is the routing protocol for these types of networks, and we can get all of these metrics for the individual links. But let's return to the meter itself. If we were to say, take a look at this meter and had to troubleshoot it, we got some very basic troubleshooting tools. And that's very appropriate for an OT environment because basically it's either up and I can talk to it, or it isn't, and now I have to try and figure out why. So for instance, I can run, just with a single click, I can run a ping. I don't have to know the commands. I don't have to somehow get into that device or get into the router. I can just, with a one click, run a ping, and then what matters to me as an OT operator, it's completed successfully. I can similarly run a trace route, just again with a single click. So I can, kick this off. If I want to see all the details, I have all those details available to me. But again, I probably just want to zero in on the message that, hey, that completed successfully. So that's the first stage. I want to just show what it looks like when everything's working. You can see in this environment, I have all 2,200 devices that are up. Well, in real life, that's not the case. This is a theoretical environment, fully virtualized, and it's not indicative. In the real world, I'm never going to have all my devices up. I'm always going to have a degree of outage. So I'm going to create an outage right now. I'm going to running some background scripts to do that right now. Now, another thing to keep in mind is that from an OT perspective, we are actually monitoring operations all the time. It's not like in an enterprise space, you're not going to have people staring at screens looking at what's going on in the network and in the clients in the network in such an environment. But in an OT environment, absolutely. They have entire command centers that are very secure, some of them underground, built to resist earthquakes and even worse catastrophes to make sure that the operations are as protected as possible. And in the last 15 minutes, I see, okay, look, there's some outages that let me just take a look at this. some outages, 50 outages that have happened in the last 15 minutes here. And so I'm not going to necessarily troubleshoot each one at a time um, as an operations manager. I'm not overly concerned about every single last meter. I'm more interested in trends. And so, for example, I want to see, are there trends throughout that last shift that have really taken out a lot of things? I'll show a broader example. Let me expand my time horizons. In the last 7 days, for example, we can see that for most days, very relatively few events, but on April the 18th, we had a massive spike in events. And these are the type of trends that are of high interest to an operational manager rather than every single last uh, device going out. So we want to try and get a sense of what's gone on to cause these type of trends. So let's go back to our field network and see what we can do to troubleshoot, because like I said, I've just created some outages. And yes, that's confirmed right here. You see, instead of all 2,200 devices being up, I see that I have some that are down. So if I look at my whole network, well, I got a lot of devices here. So some of them are green, some of them are covered gray as an outage. So I might just want to filter out and focus my attention on these devices that are out. Now, I want to focus on trends, and so I might want to select some of these devices, and I might be interested, for instance, on changing my view to say, okay, it's not just a matter of a single device, but maybe I want to see if there's anything geographic that might account for this particular trend being out. I might want to switch my view to a satellite view. Perhaps this is an area where there's a lot of trees, and it's very common for a branch to fall on a power line and thus knocking out some electrical circuits, and maybe I can get some insights if something like that has happened. In this case, no, I don't see a lot of trees, so I have to keep looking deeper. Now, if it's a single device, let me take a look at this. I can't, if I try and ping it now, I'm not going to be able to. I know that I see that this device has indicated an outage, but I don't know the reason for the outage. It could be a network reason. I've lost connectivity. It might be authentication. You see there, my ping has failed, so I can't reach that device, or it might be a loss of power. Well, what other clues can I have at my disposal to troubleshoot this? Well, I can take a look at the details of any single meter that's within my infrastructure here, and this pivots all the information around that particular meter. It's very similar to if you're coming from the IT world in DNA Center, we have a device 360. All the data is pivoted around that device. And if I look at that meter, I can go into the events and see what the last known message that it sent was, and it sent a message that's called a power outage notification signal, so a PONS message. So this is a dying gasp. It has just enough power in a battery, in a capacitor and a battery combination to say, I sense that I'm losing power, but just before I do, I'm going to let you know that this has happened so that you understand why you're not hearing from me. So this is a very definitive proof of a power outage of that specific meter. And so I know that it's not a network, it's not that kind of an issue. And that gives me a clear idea of what the overall root cause is. But is it to that meter alone, or is it to many meters? That's why I want to look at that overall trend. Now, if it's just a single device, coming back to my map, I'm not going to roll a truck to fix a single meter. A truck roll in this type of industry can cost me $1,000. That's 10 times more than the cost of the meter itself. And so as such, that would not be an effective use of my resources. But what if, in turn, it wasn't the meter that was out, but maybe a more critical device like my CGR router that's at the center of it all? For instance, this CGR router that I've been focusing on, if I take a look at the mesh statistics view of it over here, I can see that it has 1,200 devices that are connected to its resilient mesh. And therefore, if this device is out, Well, now I've got a much more serious problem on my hand because it's, all these other devices are dependent on it. So now what do I do? Well, in this case, I would be likely more inclined to do a truck roll after I've done all my remote troubleshooting. But let's assume that I can't do a ping or a trace route, which we've already demonstrated. In this case, maybe I've tried everything I can and I have no alternative but to roll a truck to that site. Well, we have a very nicely integrated workflow. So for instance, we've tried our basic troubleshooting. We can then say, okay, I have no choice but to create a work order. I really like this. It's pretty slick because I can give the work order a name, demo, CGR work order, and then I can define the details of the device. I can even specify, oh, who's the technician? Oh, let's get that Tim guy out there. Oh, and he's going to go on site and make that fix. And I can even specify a window. I can say, you know what, I'm only going to give him access for the next 24 hours to this device, not unlimited access to it. I open a window for that troubleshooting, and then all of this information gets sent to a software agent on the technician's Toughbook. It's a complementary software that Cisco we also make. It's called IoT Device Manager. So all the information about um, the device in question, the SSID that will be needed, the credentials that both get on the wireless network so that from the ground he can talk to that CGR router that's way up on the pole to see, okay, if it's still alive, it just doesn't have the network connectivity or what's going on. It has downloads all the certificates, everything they need to do the troubleshooting in the field is now sent and it's integrated. And likewise, when the job is complete, it all gets integrated back into the FND database, and then it can even be exported via APIs to tools like ServiceNow to maintain that overall workflow tracking and the details of what's gone on. And the last thing I'm going to cover here is with respect to firmware updates. So for example, we talked about we're dealing with a low power, low bandwidth, lossy network. Well, we can't just push software or firmware downloads down to the devices like we would in a regular, let's say, enterprise type of network where we just send the entire file down and we don't care about how long it takes or how much bandwidth is consumed or what that costs. But in this type of network, we have to care about all of these things because it could take an excessive amount of time, consume an excessive amount of bandwidth, and thus interfere with readings, and generate an excessive amount of cost because we're on a metered infrastructure. So in this case, then, we take all of this into account with FND. We can group all our devices together. For instance, I have over 2,200, well, actually just under 2,200 AMI devices in a single group. I upload the image that I want them to run, and I can send them out, maintain their synchronization of firmware images, and then these will be sent out using differentials or the delta, what has changed in their current firmware to the new firmware, and only that difference is what is sent down. Not only that, but the devices support resumable downloads. So if there's a TCP timeout, you don't have to restart from the top. You just resume from the last block that you left off. So very, very efficient method of transferring the firmware on down to the network device, then and these meter devices as well. So all of these benefits from a tool that's very custom designed to meet the operational needs of a utility such as an advanced metering infrastructure. And that's why we really want to highlight the field network director for this use case, especially using this type of synthetic digital twin that we're talking about that was built by engineers called Matrix. So I hope you enjoyed this demonstration. It gives you a greater appreciation of some of our IoT management tools, the unique challenges such as scale, such as low power lossy networks, dynamic changes, troubleshooting, integrated workflows, OT personas, all of these requirements that are unique to this area and how we deliver on those requirements with our technologies. Hope you've enjoyed it. Thanks very much for taking the time.